Okay, Pre-Calculus BC, section 9.2, page 4. You need your peach-colored polar graph summary sheet out. If you don't have that, please pause the video, this is important, and go get it. You have that peach sheet in front of you. You're going to have to look at it while I talk about it on here. I'm recording this at home, and I unfortunately don't have one. I have one on my computer, but you can't see that right now, so I need you to have your peach sheet out in front of you. We're going to graph this limacon by hand. So I'm telling you it's a limacon, so go ahead and look at that peach sheet and see that this fits that pattern, r equals a plus or minus b times sine theta. And to determine what kind it is, we have to look at the ratio of a to b, so 2 over negative 3, and then absolute value of that. And 2/3 is greater than 0 but less than 1, so we know that we are going to graph a limacon with an inner loop. Okay. We also know, because this is a sine graph in here, flip over to the other side, page 2 of the polar graph summary, and read the last couple of sentences there on the page. And it talks about if a polar graph contains a sine function in it, then it will be symmetric to the 90-degree axis. Okay, that's important. Now, this is actually enough information once we get some points. So what we're going to do is to make a t-chart here with r and theta. And the thetas that we're going to use are 0 degrees, 90 degrees, 180, 270, and then back at 360. Okay, so let's put 0 in here. Sine of 0 is 0 times 3, 0. 2 minus 0 is 2. Let's put a 90 in here. Sine of 90 is 1. So we have 2 minus 3 times 1, or 2 minus 3, negative 1. 180, sine of 180 is 0, so that's 2. 270, sine of 270 is negative 1. So we have 2 minus 3 times a negative 1, which ends up being 2 plus a 3, or 5. And then 360 back to 0. All right, let's graph this. Let's call that 1. So every 2 rings is 1 unit. So there's 1, here's 2, 3, 4, and then 5, all the way at the outermost ring. All right, just going through and plotting some points then. Let's do 2 at 0 degrees. So at 0 degrees, the r value is 2. At 90 degrees, the r value is negative 1. So 90 degrees, and then negative 1 is going to take us through to the other side. That's right there. 180 degrees, the r value is 2. There. 270 degrees, the r value is 5. It's all the way out here. And that's it. Now with these 4 points, we have enough to actually draw a limacon with an inner loop. That limacon, when we have a loop, will always hit the pole, and there's going to set up your inner loop. And we know this is symmetric to the 90 degrees, so we're going to kind of have to figure this one out. The other thing that happens is the limacon actually kind of gets wider as it passes through that point. Some people want to make this kind of almost go vertical here, but it doesn't. It actually is pretty wide. limestone is pretty wide coming around, and then this starts curving back around to here. And then up this way again, coming through, and see how it comes through kind of on an angle here, not coming straight down, but an angle and widening out. So there's that limestone. I'm just going to make this a little thicker because you can't see this green very well in here. And there's our limestone. All right, let's take a look at this next one. We're going to graph r equals 2 cosine 3 theta. So please look on your polar graph sheet and see if you can figure out what form this is in. R equals 2 cosine 3 theta. That's a rose where A is 2 and N is 3. All right, now if we just start plugging through the information that's there, we know that if N is odd, there are N petals. So N is odd, so there are 3 petals. They are 360 degrees divided by N apart from each other. So 360 divided by 3, they are 120 degrees apart. And each petal is A units long, so A is 2, so 2 units long. And because this is a cosine with the rose, the first petal is at 0 degrees. All right, so we know we're drawing a rose. Here's 0 degrees. It's 90, 270, 180. Same scale, I guess. So here would be 1. There's 2. Let's put this in orange. All right, so first petal is at 0 degrees and it's 2 units long. So that puts that end point of the first petal out here at a 2. The next petal, 2 units long, is going to be at 120 degrees. So let's find 120. Here's 120. 2 there. And the next one is another 120, which would be 240. Right there. And it doesn't seem like much, but there's kind of the tips of your 3 petals. The petals are always going to emanate or start at the pole, and they come around, and the petals are pretty roundish. Here's that first petal. Another petal, there's the length, the outside length, so we're going to round this one around. And the last one, down here. Oops, I think I misread that circle here. This one's supposed to come out there. Yeah, there you go. And I don't think I can cover this up, we'll see. Yeah, my liquid paper's not, or it's not liquid paper, my paper tape. Oh, that's better. And pencil, pencil, pencil to fix the lines and the curve. There we go. All right, so this is what I'm talking about when you look at your assignment sheet, which says graph some of these on your calculator and copy onto paper. This is what I mean by do this by hand. So use that sheet to help you sort through and figure out what type of polar curve they are, and then get a little bit of information and then sketch those graphs in. Thank you very much, and please join me on page 5.